So the other type of wave that we need to look at is longitudinal waves. So sound waves are made up of vibrations in air particles. Now, these are an example of longitudinal waves, and this is where the sound will travel from the speakers to the girl's ears. The vibration that makes up that wave will be backwards and forwards parallel to the direction the wave is travelling. Hence longitudinal waves, because the vibration is along the direction of wave travel. For example, if you were to watch the hairs on the cat, you see those hairs moving backwards and forwards as the sound travels past the cat. Okay. So if we're using a slinky to represent this, we've got our hand moving backwards and forwards, and a wave travelling from left to right. Okay, so the vibration of the wave is like this, the wave is travelling this way. Now, parts, we have some more names here. The part where the slinky is squashed together, or the air particles in the sound wave are squashed together, called compression, and the place where they're stretched apart in the wave is called rarefaction. Compression, rarefaction. Sound waves are longitudinal waves, so when somebody speaks, what your ears are detecting are back and forth vibrations in the air particles. P waves in earthquakes, primary waves, are longitudinal. Okay, I wouldn't use those as examples because it's easy to mix up the P and the S with transverse and longitudinal. So how do the particles move? You see the movement of the particles is backwards and forwards as the wave moves from left to right. Increase the frequency, and they're vibrating more often. Decrease the frequency, and they're vibrating less often. But again, the particles don't actually change position overall, they just move back and forth and then back to where they were at the start. So, the wavelength being the distance between two similar places, it could be the distance between two rarefactions or the distance between two compressions. Again, we're using lambda, and again we're measuring in meters. So then, classifying transverse and longitudinal, we'll do this in the Google Doc that goes with these two presentations.